Hello, everyone. Um, I'm the last guy between you and pizza, so I'll try to be fast and more engaging, and I hope you will enjoy it, and maybe it will inspire you somehow. This is the title of my presentation. I've tried to come up with something smart, but actually, it's just about some small project I'm doing at Kiwi. So I hope you will have fun. Um, Yeah, about me, my name is Artur. I'm working at Kiwi in Barcelona office, and I'm in the business intelligence department. So let's start with the problem. As you all probably know, Kiwi is pretty big company, and we deal with a lot of data. To just like have an idea about the numbers, I think most of you have this piece of paper which says about the data we have. So it's like terabytes, a lot of data we have every day, and this. So I don't need to explain this. And we have analytics team, and we are trying to be data-driven company. So work of analytics is pretty important. So there are like 20, 30 people there, and they produce quite a lot of dashboards, charts, and stuff like that. And we need somehow distribute this data through across all of the kiwi.com, which is like 3,000 people. So this chart I made yesterday just to make it clear. So usually how it works, people go to the Slack. There is a separate Slack channel. If they want to find something, they just ask a question there, or they have some request there. They put request there, and people from analytics, they just answer it, and it can take quite from 1 hour to 2 days. So you have to wait, and people usually ask repetitive questions. They don't bother looking in the history, and yeah, this is pain in the ass. So to save people's time, decided to make a chatbot, quite a buzzword. I don't know if now is a buzzword, but like 2 years ago it was, right? So let's try to see how we did it. Yeah, this is just the solution. This is how it looks like. Yeah, by the name of the bot is Alfred. It's not my decision to name it like that. It's just my manager told me to name it. And this is how it looks like in Slack now. So the guy asks a question and then analytics answer it. So they provide him a link to some dashboard. And this is how it's supposed to be looking. So you ask a question and then it's like working like a search engine and you give you some relevance. So instead, for example, the guy asking how many bookings we had on Sunday and the analytics girl giving him a number, the chatbot will just give him a number, right? So cool. So the main technology stack, how many of you know the Dialogflow? Raise your hand. Or worked with the Dialogflow? Okay. What? 2 people. Elasticsearch? Okay. More. Neo4j? Oh, less like Dialogflow. All right. So Dialogflow is the Google conversational platform. It's good if you need to fast prototype your chatbot or conversation solution. It's not really flexible, but you can use it. Elasticsearch is one of the best full text search databases, and Neo4j is just a graph database. This is the schema, how it works. It's a little bit complex, but let me explain you. So the user goes to Slack, he asks a question, then this message goes to Dialogflow. It is classified there, so we understand what user wants on the side of Dialogflow. Then the request goes to the Elasticsearch, and we search in our database the things we want to search. And then there's also an Neo4j database, which kind of enriches the result from Elasticsearch. And I'm going to explain how it works. This is kind of the same schema. I'm going to skip it. Let me explain you a little bit about Dialogflow. As I told you already, this is like a conversational thing. It has a machine learning model inside, and you just can put your training phrases there, and it will classify your messages. So we have only 3 classes. One of them is the popular questions, the questions we kind of want to give the number or the link like right away. For example, one of the questions could be how many bookings we had last week or yesterday. So we want to give the number straight away. And there is a small talk just to say, hi, how are you? And the rest, which is actually the main topic of this presentation, is when it's unclassified, we search it in database. Yeah, the small talk just to make it user-friendly. Other questions, when we don't know which message it is, we cannot classify it, we just go to Elasticsearch and search it. Problems with Dialogflow, that it's kind of difficult to train. I mean, it's easy if your solution is easy, but if you have like about 100 classes, then it's kind of not really stable and you cannot control much, and the API is kind of so by the way, in Elasticsearch you can actually kind of, in a training phases, you can put like the words which you want to recognize, so it can give you the for example, it can extract the names of the countries or the date times or the or something you just want to extract from the text, but you have to put it there. So it's like thousands of training examples, and to put it manually is kind of tedious. So in order to solve that, we made some script which generates the data and uploads to the Dialogflow using APIs. And the problems there is that when you start to using it, there are some API limits, and the docs are not really so good as you want them to be. Then, okay, after Dialogflow, we can understand our users. So what's next? Let's just look at the databases. Elasticsearch, as I already told, is the text search database, and Neo4j is to store the relations, is the graph database. So Neo4j is good for prototyping. You may ask me, why do you even need graphs in this solution? Yeah, I can answer, or at least I can try to answer. Is to store the connections. For example, which user created which chart or dashboard, or which user viewed which dashboard. So we can have this data in the Neo4j, and later on we can get some insight from the graph database. For example, we can recommend to the user which dashboards he wants to see and stuff like that. And also it's useful when you want to create a big graph of the data flow inside your company. So if something goes wrong on the one side, you can see like what will it affect later on. So in our case, Neo4j, we used to calculate some statistics of the documents. For example, number of views per each document, or distinct people who view the document, or the page rank, which I'm gonna explain soon. This is just some code, how the document looks, how the document model looks in Elasticsearch. It's not really important. This is how it looks in Neo4j. As you see, there are three types of relations: the who created the document, who consumed, and who modified. This is the same, but for document. So when I started implementing it, there was a problem how to connect both databases, because you're going to use both databases and you're going to store your data in both of them, and you have to manage somehow. So the first solution we've tried was using the plugins. There are some plugins to connect Elasticsearch and Neo4j. So when you call Elasticsearch, it will call Neo4j and the running time. So it should be fast. But it didn't work because these plugins are not supported. They're for the old version of Elasticsearch, which is like second version. I don't know if someone uses the second version, but the most recent, I think, is 6. So you can imagine it's pretty bad. So instead of that, we just decided to kind of just call both databases from the backend. Why not? It's a little bit slow, but just that's what we want, right? This is just some code, not relevant right now, because we want pizza, right? So far, we discovered Dialogflow and just explained Elasticsearch and Neo4j. And this is just example of code. How you can use Elasticsearch using Python libraries, and just examples of some queries, not really important. So the interesting thing is when you want to, when in Elasticsearch you want to account for the word order. So as you know, for example, for this query, bookings last year, you want to score the first sentence more than the last sentence, because it's kind of the first sentence matches more the query than the second one. But Elasticsearch, if you just use it out of the box, if you will just use the match query, it wouldn't allow you to do that. There is the match phrase query, which kind of matches the phrase, but it also filters by the keywords. So it will have to have the bookings, the last, and the year. So it will have to have 3 words. And there is also a special parameter you can tune, but still it's not really flexible. So another standard approach is to create the second analyzed field. So you have the standard field, like the index, which is just single words. And the second field is, let's just add there the so-called shingles, which are just the sets of words. For example, the sets of words of 2, the last year, or the 3, number of bookings. So when we will search, it will kind of help us to account for the word order. Right? This is again some code. Neo4j. If you don't know, it has some SQL inspired language to make queries to your graph. It's really easy and it's okay. Also, I want to mention that Neo4j have some problems with iterative computation. So if you want to calculate something on your graph, it will calculate it in your RAM, and if your graph is really huge, then it will just crash. So you have to use some libraries for that. And this is just example of the query. It's not really hard, but yeah, you have to read it. And let me tell you about the PageRank. Who knows about PageRank? Something? Some people? Okay. So the PageRank is the algorithm which was initially created by Google in their search engine, and they still use it. So the idea of this algorithm is that they created it for pages. So the idea of this algorithm is that the page which has more references to itself will have more score than other pages. So for example, if you have, I don't know, Wikipedia, and a lot of pages have links to Wikipedia, the Wikipedia will have high score, basically. So we can apply the same algorithm for our documents, dashboards, and stuff like that. The problem is that our graph is kind of bipartite. The bipartite graph is the graph which has 2. Well, it's not really exact definition, but in our case, our graph has 2 types of nodes: is the user and the document. So you cannot apply PageRank to this graph. You need to have only one type of nodes. So what do we do in this case? So on the left, you have the initial graph. You have the user node and the document node, and the edges are which user viewed which document. And to use PageRank, you need to convert this graph to some other graph, which will kind of be the same, will have kind of the same information, but it needs to have one type of node. So to do that, let's just create a new graph, and the nodes will be the weight of the nodes between the documents will be the number of common people who viewed both of the documents. So it will kind of store the same information. And we can apply PageRank to this graph. This is how you use later on when you calculate PageRank and you calculate some statistics. You can use them to modify the score in Elasticsearch. So if your page has a high PageRank, the basic score will also be affected. And okay, not important. So you may ask me, there is this outfit, right? Does it work or not? Is it good or not? So the answer is it depends. It depends. If you use it as the search engine, it's good. It can actually help you to search in the existing dashboards, documents, and stuff like that. But if you use it as like, if you speak with the Alfred like with the real person, as this guy did, then it may give you some misleading results. For example, in this case, he's want to Alfred to search for something, but he shouldn't put search because the bot will actually try to search for the word search. So that's why the results are not relevant. So to improve that in the future, I want to implement some ranking algorithm, the machine learning algorithm, to kind of get rid of these problems. And other problems would be to change Neo4j to some other graph database, because if, well, from my own experience, Neo4j was pain in the ass in the production. It will just fail without any reason, like once a day. So I would suggest using in production some other database. There are quite a lot of them nowadays. And I would get rid of Dialogflow because I cannot control everything there, and yeah. So sum up, we created some solution, the chatbot, which is helping analytics to answer the questions, and the time will show if it's actually useful or not. Yeah, thank you. Yep. There is the guy who always asks questions.
Here, who? Oh, I'm coming.
Hello, thank you for your talk. My question is, which part of questions to your channel in Slack are answered right now with your bot, and also which part is answered correctly?
It's a good question, because we just implemented it. Not a lot of people using it, and mostly the people who use it is actually analytics channel, just to search faster in our, because we have a lot of data sources, so they use it to search for some questions. But for right now, not a lot of people use it, so I cannot answer for that. Yeah.
Thank you. I have a security question. If I'll ask Alfred to drop a table named table name, will he query this?
No, it's like if you ask Google to drop a table in Google, it cannot do that.
Okay, so you some kind of sanitize or filter these queries to him?
Yeah, I haven't actually thought about it. It's a good question. Yeah, thank you. I will try to see.
Okay, thank you.
I see you. Thanks for the talk. And actually, I have two questions. First, are there any real reasons you choose to use Neo4j like any graph database? Because the problem seems pretty easy to solve this kind of relation database, like MySQL or whatever. And the second one is, are there any plans to maybe possibly open source the Alfred just to share your work?
Yeah, so the answer for the first question, I chose Neo4j because, well, I chose Neo4j from other graph database because it's quite easy. It has API and some visualizations, and it already have some graph algorithms implemented there, so you can just use it. And why I used a graph database instead of SQL. Well, for SQL, you'll have to write some joins in order to go through the graph. Sometimes it's also pain in the ass. And also, Neo4j, as I said, have some algorithms like PageRank, so I can just use it. Yeah.
But it seems just you have one kind of relation and that's it.
Not really. There's like created, viewed, and modified. And basically, if you have this graph, you can later on you can use it for some more complex stuff.
And about open sourcing?
Open source, I haven't thought about it, but maybe. There's someone there.
I have a question about your boss. His name doesn't happen to be Alfred, does it?
About the what?
Your boss, the one who named the chatbot.
No, his name is not Alfred.
All right.
I have no idea why he named it like that. You just need to have some name for it.
Thank you for the talk. I know that the company that is working on the similar Slack search bot, but is the company use Vit.ai, and they switch from Dialogflow to Vit.ai. Have you tried?
No, I haven't tried Vit.ai. I just tried Dialogflow, but I think should be similar. They should have similar problems, so that's why I would just move to my own solution.
Thank you.
Yep. Oh, more question. Okay.
Thanks. One quick question. What are the problems? Can you share? Why do you think those two solutions share the same problems? Dialogflow and v.ai.
As I know, I haven't tried a lot of things. I just tried Dialogflow, but I made some research just searching in Google, and all these platforms seem very similar. And you just provide some training phrases there, and then it kind of trains the machine learning model. But as I said, when you don't know what's going on there when it's training, it's kind of difficult to. Well, when you do machine learning, I think from my side, from my point of view, you need to have it here so you can test your hypothesis and stuff like that. But when you just have some API, which is kind of limited, which have limited things in it, it's kind of hard to test your solution and to train it. Yep. Thank you.
Our questions are over. Or do you?
I think, yeah.
Any questions?
That's fine.
No. Thanks for the talk.
Thank you.
And this is for you. Thank you.
So my talk was good, right?